everyone, this is SOD Consult. This is the part 2 of our taking off for substructural works. So for this part 2, for the part 1, we have taken off, we'll start our taking off on site clearance to disposal or retaining of topsoil. So for this part 2, we are going to start our work from trench excavation. So here now we want to modify our previous work. So for our Excel, this our Excel, now as we are working on it, we can start using it as our templates. So for our Excel, I'll try and let us tweak some works in our Excel. For here now, this our side length and side width. If I'm to work on these templates, I would like to create a pattern in which I will understand. So for this column here, I can try and change color my box here. So the main reason for putting color in my box is to give me an idea that if I want to edit, in case I want to use this work for another work as a template. So if I color my box here, this color shows me that if I want to edit some works here, these are the work I'm going to edit. I'm not going to touch any other work than the work in red boxes. And you can try and change the answer you get in your squaring column as blue. Also, I try and change it to blue. So if I'm working here, I will know that all my answers are in blue. So sorry, Ctrl Z. So you can change this box here to this is filling color, and this is font color. So if you mistakenly press here, the color of the font style you are using, maybe Calibri or Nita Roma, is going to change. But so that's it. For the retaining of topsoil, sometimes according to engineering specification, it may be your topsoil excavation may be 0.15. Topsoil excavation is clearing away of vegetative soil offsite. So you may specify 0.15 or above. So you can, because this one is editable, you can also change it to red. So like this. Your work will be following due process. So let's start our work from trench excavation. So trench excavation. Let me write trench excavation. So our trench excavation is in meter cube. So meter cube. And just put it as superscript. So meter cube. Wow. And this error in my parts, you can just copy and paste. Okay, that's true. So trench excavation. For our trench excavation, we have 3 important points. We have the main guards, external guards here. That's right. What is the length of our external guards? Length 11.05 by 21 points. So it's already here. So everything we are looking for is already here. So can you say 11.05? So that is the main purpose of writing, doing this work calculation the other time, to avoid us repeating, like going to our drawing to check all the time. So here now I can just write is equal to, just click here. Can you see? That's done. Is equal to, just click here. So the main purpose of working with Excel is to give us a fixed template. So maybe you are now working, you want to use this work for another work, and maybe your site clearance, our site clearance is 18.25, and our width site length is 18.25, and our site width is 35.6. Write that down. And our site clearance is 64 649.70 meters square. So maybe we are to work here in our template. Maybe we change our 18.25 to 20. For example, 20. Let me change this. Let me try and change this to numbers. So as to take everything in 2 decimal points. So that's it. So maybe the here is 20. Can you see? This our answer changed from 619 to 712. Can you see? Maybe our building length, which is 11.05. Let's change it to 15. Wash the topsoil excavation and our retaining. Wash both. So let's change it to 12, for example. Can you see? Can you see there's changes in our topsoil excavation and our retaining of topsoil to retaining of topsoil. So what am I referring to this? The main reason I'm referring to this is that when you are preparing your template for the first time, you will encounter some difficulties, some hardship. But if you are to use it all over again, it will make your work more easier and your work more faster. So let me try and change my drawings. I don't want to have errors. I think this one is 18.25 and I think this one is 11.05 if I'm correct. As you see, changes are being affected. So that's it about that. So for our external gas, so I said our external gas. So we have already written the building length and the building width. So to find, now I said our gas is just like a perimeter. That means we have gotten the length of this one, the length from here to here, which is 11.05, and you're already getting your length from here to here, which is 12.83825. So that means this side plus this side plus this side plus this side. That means this side plus the length plus the width you had, you multiply by 2 to get this other side and this other side. So that is just the simple logic behind that. You have area of a rectangle, you have a perimeter of a rectangle, so it's 2 into L plus P. That's it, just to get the perimeter work of our item. So that's it. That means this one plus this one, your answer here can use is equal to this one, what you get here plus what you get here. That's it. Are you see? So that's it about that. So and multiply by 2, put 2 here, multiply by 2. So and answer you get here can just use is equal to this one times this. Sorry, this one is equal to this multiplied by 2. So that's it for our perimeter. So you can try and rule the under and rule the top. So can you see? That is our perimeter. That is so we have to next item is to less. The next thing to do next is less our corners. Less our corners. You know, this our length is from this 11.05 length is from this corner to this corner. This 21.825 is from this end external to external. That means if you have to take your measurement, this work from this measurement from this external work to this external work. So if this line, you want to like measure this line from this end to this end, there will be like overlap from here to here, which is 225. That means you have to deduct the overlap at this corner, the overlap at this corner, the overlap at this corner, the overlap at this corner. Can I explain that again? No, your measurement is from external to external, maybe which is 11.05. From this external to this external is 11.05, and for this length, which is 21.825, is for this external to this external. So the external one for this length, and for this width, there's something like overlap between these two dimensions, which causes it to have a positive this extra measurement. So you have to deduct the 225 here, 225 here, 225 here, 225 here. That means we are going to less 4 times 225, 4 times 225 here. So let's 4 by let's put here less 4 by 225. 4 by 225 means 4 times 225, which is 900. Convert it to meter, which is 0.9. So what you get here, so equal to this minus 0.9. Are you see? 64.86. So that's for our external guts. So that we have gotten our external guts. So I can just try and copy this one and write external guts. So now we are done with our external guts. So we have to work on our internal guts. Then for our internal guts, let's check our drawing. This is our drawing. So these are internal guts. Our internal guts can be divided into horizontal and vertical. So to make your work more easier, you can decide to name your horizontal, like you can name it H1, you can name this one H1, H2, H3, H4, and so on. Also, you can name your vertical as V1, V2, V3, and so on. So that's how we come about our internal guts. Also a thing to take note in our internal guts is to less spread. So whenever we have T junction like this, we normally deduct spread. Let me take you to our foundation plan. If you notice the dimension from here to here, our excavation for this vertical trench is not starting here, it's not ending here, whereas it's starting from this place and ending here. So the space here from this block to here is 2.5, and the space from here to this excavation is 2.5. That means we have dot 2.5 to 2.5. We have to less twice spread. So we have to less twice spread, and so that's it. So for our work, sometimes in our foundation we might have two sets of block. I mean, we might have two sizes of block. We might have 150 mm block and 225 mm block. Though it's not common to have both, but if you have both, there's a way you can take off for your different sizes of block. For example, let me just do a rough estimation here. Maybe you for your horizontal block, you have horizontal. This side you have, let me try and extend this one, this also this. So for this one you have 225 50 mm. So you have to list out, you have to label all your horizontal grid or your horizontal trench. Maybe H1, H2, H3, H4. So the ones that fall under the 2 to 5 mm, you write it down. Maybe you have, for the H1 you have 4 meter, here you have 5, here you have 3. Also for this you may have 2, you may have 4, you may have 3. So I now sum the total. We now sum the total of this one. Sum from here down to here. Press enter. Also sum this one. Sum from here down to here. Press enter. So you likewise do the same thing for vertical gate. So for your 2 to 5 mm block, because our external gate is 2 to 5, we write it under. So because of our external gate is 2 to 5, our external gate is 2 to 5. So your horizontal gate, which is 2 to 5, plus your vertical gate, which is 2 to 5, you add the two together. Your horizontal gate, which is 150 mm, and your vertical gate, which is 150 mm, you add the two together. So the one that have 2 to 5, you add it together with external gate, because our external gate is 2 to 5. So the one that the internal gate that is 150, you write that separately. So you have to take off for that separately. But for the purpose of our work, let's assume we are only having 150 2 to 5 mm block for our trench excavation. So for this work, I will assume let me assume 98.04 for our internal gate. 98. So our total gate now, so for our total gate, we write is equal to this plus this. So that's our total gate. So I said for our trench excavation, we have to take note of 3 things: the main gate, the depth, and the width. So for our width, for example, our width of excavation, so our width is 3 times the size of the block, which is 0.6. So we check our drawing is 0.675. 0.6. We check our foundation plan. The size of our trench is 0.675. So let's put that down. 0.68. So for the depth, though is not stated in our drawing, but let's check the section. Let's assume 900 mm for the depth of our foundation. So let's put that 0.9 as the depth. So let's book it in our dimension column. So it's equal to, for our main gate is this. Let's enter. For our width is equal to this. Let's do that down. And for our depth is equal to this. So let's do that down. So in our there's a mistake here. So equal to 0.9. So let's do that down. So to find the summation in our squaring column, instead of like doing our manual timesing, I just go to this place, press Ctrl C to copy, and come here, press Ctrl V. In Excel is allowed to copy formulas. So if we check here, check the formulas here, beta 3, so you see beta 3 times beta 4 times beta 5. So it's allowed to copy formulas. Just copy it rightly. So that's it. So here I said we will normally colored let's put our dimension into colored. For our internal gate, because it's editable, let's color it as our normal color red. Also our width, let's color it as red. Our depth, let's color it as red. So So for our width now, we change it to 0.7. Just see the first in our dimension column, our square, and then our squaring column. Let's change it to 0.7. Can you see? It's changed here and it also changed here. So that is the main purpose of using Excel to form our templates. So that's all about taking off for trench excavation. Taking off for trench excavation. So in our part 3, we'll be starting our taking off from leveling and compacting. Leveling and compacting. So that's all about the training of today, about everything today. So if you are watching our channel for the first time, I would like us to like our video, subscribe to our channel, and please like our video.